See, yesterday we have studied three formulae. One is what? Multiplication by e raised to 80. This we have discussed. What it says? If L of f of t is equal to capital F of s, then L of, if I multiply ft by e raised to 80 times f of t will be what? It is f of s minus a. What I should do? I should replace s by s minus a in f of s. That is, replace s by s minus a in f of s, right? So in such cases, what you are doing, you have to first you have to find out, you have to identify the function f of t, that is e raised to 80 times f of t. In this, I should consider f of t, right? So first you have to identify the function f of t, then find out L of f of t, then replace s by s minus a. So that is your means step by step procedure. Second one is what? We have considered multiplication by by t, t squared, t cube, etc. I went up to t raised to n. I have discussed this in the last class, right? So what it says, if L of f of t is equal to capital F of s, then I consider multiplication by t squared and all, then L of t times f of t. That is, I have multiplied f of t by t, then it will be minus d by ds of f of s. Right? I should differentiate f of, I have to differentiate this f of s with respect to s minus of that. Then L of t square times f of t will be equal to what? Minus 1 whole square. It is d squared by ds squared. That is, I should differentiate f of s twice. Right. So that is L of t squared times f of t. Similarly, L of t cube times f of t. So what it will be? It is minus 1 whole cube. It is d cube by ds cube of f of s. So like this. So I can generalize this and I can write this as what? This I can write as, if I continue like this, L of t raised to n f of t. If I multiply f of t by t raised to n, so this will be what? The generalization of this, minus 1 raised to n d raised to n by ds raised to n of f of s. That is nth order derivative of f of s. So like this is the second formula we studied in the last class. This we have solved even the problems also. The third one is division by t. Division by t. Right. So what it says, I have to divide f of t by t. What is L of ft by t? So what the theorem says is, if L of f of t is equal to capital F of s, then L of ft divided by t. L of ft by t will be what? Integration from s to infinity f of s ds. This is what we have discussed in the last class also, and I have solved one problem also. What that problem says? Example, I find the Laplace transform of the following. Right. So the first problem we considered was sine t sine 2t by t. Now here in the previous class I considered sine 2t by t. Suppose if it is sine hyperbolic, so it becomes very simple. So I consider now sine hyperbolic sine hyperbolic 2t by t. So what is my ft? This is clearly of the form ft by t. Correct? No, it is ft by t form. What is ft? ft is what? It is sine hyperbolic 2t. Right? It is sine hyperbolic 2t. Therefore, what I should do? Therefore, what I should do? Consider L of sine hyperbolic 2t. So what that will be? So that will be equal to what? It is a over s squared minus a squared. So it is 2 over s squared minus 2 squared. Right? S squared minus 2 squared. This is sine hyperbolic Laplace transform of sine hyperbolic t. Therefore, L of, see, in the previous class, this it was sine 2t. So it was 2 over s squared plus 2 squared. But it is sine hyperbolic 2t. Therefore, it is 2 over s squared minus 2 squared. Clearly, I can make use of a squared minus b squared is a plus b into a minus b. Then resolve it into partial fraction. Then find out the integral. So L of sine hyperbolic 2t by t will be what? By properties of, by this property, it is s to infinity, right? F of s ds, that is 2 over s squared minus 2 squared ds, right? It is 2 over s squared minus 2 squared ds. Right. Now I have to integrate this. So this will be equal to, I just consider that integral. Now I solve this integral. So this will be equal to, that is, I just start now. That is L of sine hyperbolic 2t by t will be equal to what? It is integration from s to infinity. It is 2 can be taken out, 1 over s plus 2 into s minus 2 ds, right? S plus 2 into s minus 2 ds. So this I can write as, so this, what I will do is I will consider this separately. Consider, because I have to resolve this into partial fractions, 1 over s plus 2 into s minus 2. Let this be equal to what? A over s minus 2 plus ab over s plus 2. Right. So a over s minus 2 plus b over s plus 2. So this, so now if I take LCM and all, taking LCM and simplifying, we get, it is actually resolving it into partial fractions. Say this, you have studied. So this is equal to what? A times s plus 2. 1 is equal to, then I cancel out s minus 2 to s plus 2 on both sides, plus b times s minus 2. Right. What I did, a times s plus 2 into b times s minus 2. I multiplied, cross multiplication like, so s minus 2 to s plus 2 it will be. So left hand side also s plus 2 times s minus 2, those two cancel. So you are left with this. Now what I should do, put s is equal to 2. If I put s is equal to 2, see 2 minus 2 is 0. So this becomes 0. So 1 is equal to 4a. This implies a is equal to 1 by 4. Right. Then I put s is equal to minus 2. Put s is equal to minus 2. So then what I get, 1 is equal to, if I put minus 2 for s, a will be minus 2 plus 2. So this becomes 0. A term will not be there. Minus 2 is minus 4. So it is minus 4b. So this implies b is equal to what? Minus 1 by 4. So therefore, what I will do, L of sine hyperbolic 2t by t will be equal to what? It is twice integration from 0 to infinity. Instead of 1 over s plus 2 into s minus 2, this I have resolved this into partial fractions. I write this as what? A over s minus 2 plus b over s plus 2. So a is what? 1 by 4. So it is 1 by 4 divided by s minus 2. Then plus b is minus 1 by 4 plus minus 1 by 4 over s plus 2. Right. So ds. So this ds. So what this will be? See here 1 by 4 I can take it outside. So 2 times 1 by 4 it will be 2 by 4. I have taken this outside. So 2 by 4 integration from 0 to infinity. This becomes what? This will be 1 over s minus 2 plus. And it will be minus, I'm sorry. This will be minus 1 over s plus 2 ds. Right. So 2 by 4 is 1 by 2. So this will be equal to what? 1 s to infinity. I am extremely sorry. This is s to infinity. S to infinity. So it is 1 by 2 integration from 0 to infinity. It is ds over s minus 2. It is integration from s to infinity minus integration from s to infinity. It is ds over s plus 2. Right. So this will be what? So this will be equal to 1 by 2. It is log of s minus 2 minus log of s plus 2 from s to infinity. Right. S minus 2 over s plus 2 from s to infinity. This we have used log a minus log b is log of a by b. So this I write as what? Half of log of s minus 2 by s plus 2 from s to infinity. Now I should take the limit as s tending to infinity minus I should take the limit as s tending to s or put s is equal to s. So this will be what? Half limit as s tending to infinity log of s minus 2 over s plus 2 minus log of s minus 2 over s plus 2. This what I did, this is the lower limit. I have replaced s by s only. So I get the same term. So this half is common for both these terms. So as we have discussed in the last class, see this from here I take s outside. So this becomes 1 minus 2 by s. From denominator also I take s outside. So that also becomes 1 plus 2 by s. As s tending to infinity, my 2 by s and minus 2 by s that tend to 0. Then I get log 1 here. So log 1 will be 0. So this term gives me 0. Therefore, what I get? So this will be equal to what? Half of minus I can invert these two. I can write this as what? Half of log of s plus 2 over s minus 2. So this is my L of sine hyperbolic 2t by t. So this is my uh, second second problem which I have solved in this on this problem on this property. Whenever you are dividing by t, you have to what you have to do? You have to you have to integrate f of s from s to infinity. That's what we did in this particular problem. Now I'll consider one more problem. This will be the third problem of ft by t. So the third problem will be e raised to at minus e raised to bt by t. Right. Find out L of e raised to at by minus e raised to bt by t. So what this will be equal to? This will be equal to what? This is again is of the form. See, in the exam you need not write all these things. Form ft by t. So it is division by t. What is f of t? F of t is e raised to at minus e raised to bt. Right. So this will be what? Therefore, what I should do? Therefore, consider what I should consider. I should consider L of f of t. Then I should integrate that from s to infinity. Consider L of e raised to at minus e raised to bt. So what this will be? This will be equal to what? It is 1 over s minus a minus 1 over s minus b. Right. So therefore, L of e raised to at minus e raised to bt by t will be what? This will be by definition of by the property of ft by t. So it will be uh, 1 over s minus a minus 1 over s minus b ds. I have to integrate this with respect to s from s to infinity. Just a minute. So what this integral will be now? So this will be equal to what? If I integrate this, see, I get log of s minus a minus log of s minus b from s to infinity. See, it's similar to previous problem. There I was having log of x minus 2 or log minus log of s plus 2. So you are getting the same kind of expression here. So this will be what? Log of s minus a by s minus b from s to infinity. Then what will be the next step? You know this, you can easily find out. So what this will be? This will be equal to what? Log of this will be, first I should find out limit as s tending to infinity, log of s minus a by s minus b minus, I have to put s is equal to s. So I get log of s minus a by s minus b. So as you know, what I should do in such limits, I should take out s outside. So it is 1 over a by s. From denominator also s outside. So it will be 1 over b by s. As s tending to infinity, a by s, b by s, they go to 0. So I get log of 1. So finally I get this to be 0. And minus sign becomes raised to minus 1. So this will be inverted. So this will be what? Log of s minus b over s minus a. Right? Carefully observe here. It was earlier s minus a over s minus b. Since I have taken this negative sign, log of m times log a is log of a raised to m. So this will be log of s minus a over s minus b raised to minus 1. So this will be inverted. S minus b goes to the numerator, s minus a goes to the denominator. Therefore, L of e raised to at minus e raised to bt, that by t will be what? It is log of s minus b over s minus a. So this is my third problem which I am solving using Laplace transforms. The next one will be the fourth one. Find L of say cos square sine squared say t, L of sine squared t by t, right? L of sine squared t by t. So again, this is of the form ft by t. What is ft? Ft is sine squared t. Therefore, what I should do? I should consider L of sine squared t. First, I should consider that. See, I do not have formula for sine squared t. So this I write as what? L of 1 minus cos 2t by 2. This is sine squared t is 1 minus cos 2t by 2. So this will be what? Half of right? I take the, so this will be L of 1 minus L of cos 2t, right? So L of 1 is what? So this will be equal to half of L of 1 is what? 1 by S minus L of cos 2t. L of cos 2t is what? It is S over S squared plus 2 squared, or I write this as S over S squared plus 4. So now I got L of sine squared t, which is half of 1 by S minus S over S squared plus 4. So now I have to find out L of sine squared t by t. I have to find out. Therefore, L of sine squared t by t, that is division by t, will be what? Integration from s to infinity half of 1 by s minus s over s squared plus 4 ds by definition of Laplace transform. So this will be equal to division by t formula. So this will be equal to half of integration from s to infinity. See, this will be what? ds by s minus integration from s to infinity s ds by s squared plus 4. Right. So what that will be equal to? So the here, this is very simple. So it is half of log s, right, from s to infinity minus this will be what? I should put s squared plus 4 is equal to t, 2s ds is dt. So this will be half of log s squared plus 4 from s to infinity. Because I write it for your reference. Otherwise, you should be experts by this time. What I should do, because integration s ds over s squared plus 4, put in integral, put s squared plus 4 is equal to t, 2s ds is dt. This implies s ds is dt by 2. Therefore, s squared, s ds integration divided by s squared plus 4 will be equal to what? Integration of dt by 2, that divided by t. This is half of log t, that is equal to half of log of s squared plus 4. So this is your reason for writing half of log of s squared plus 4, right? So therefore, this will be equal to, I simplify it further. I write this as what? Now this is your for your reference. Otherwise, this I need not. I consider this now. It is half of, right? It is log of s from s to infinity minus, instead of half of log s squared plus 4, I write this as log of square root of s squared plus 4, right, from s to infinity, right. So now, see, this also from s to infinity, this also is from s to infinity. Log a minus log b formula I use, so this will be equal to half of log of s over s squared plus 4 under root from s to infinity. Right. Now, what is the next step? So this will be equal to half of limit as s tending to infinity log of s over s squared plus 4 under root minus I have to put s is equal to s, that is log of s over under root s squared plus 4, right. Again, if you take out s squared common from these two terms, what do you get? Square root of s squared becomes x. This s cancels. So 4 by s becomes 0. So this becomes 0. I write this is 0 because again I use this. Consider. This is for your reference. You need not prove these things in the exam. Consider limit s tending to infinity log of s over s squared plus 4 under square root sign. So this will be equal to log of limit as s tending to infinity s over from s squared plus 4, I take out s squared common, so that it is square root of s squared times 1 plus 4 by s squared. So this will be equal to what? Log of limit as s tending to infinity s over s times square root of 1 plus s squared 4 by s squared. Right, because this s squared, once it comes out of outside square root sign, that square root of s squared is x. So this s cancels. So this becomes log of 1, so which will be 0. Correct? No, 4 by s squared goes to 0. This will be 0. It is 1 over root of 1. Take positive number. So log of 1 over 1 is 1, log of 1 is 0. So you get this. Therefore, this again, since it is negative sign, once if I take that inside this log, s squared plus 4 goes to numerator, s comes to the denominator. Therefore, finally what? L of sine squared t by t will be what? It will be log of square root of s squared plus 4 divided by s. So this is your final answer. This is a ft by t. If ft by t is there, I can easily find out the integral of Laplace transform of that using ft by t result. L of ft by t is what? It is integration from s to infinity f of x ds. So this I have solved a few of the problems. I'll give you the practice problems in the class, so that you can also try these things. If I get peculiar problems, I'll solve it and I'll post it. Right? We'll just check whether I get some typical problems or not. Hmm. Sine AT into cos BT by T, cos AT into cos BT by T. S over S squared plus A squared. See, one more problem let me consider. Sine AT into sine BT by T. See, I consider. Similarly, you can go for cos AT into cos BT by T. See, this I can write as the first one. And it will be my third problem. Fourth problem. In particular, it is fifth problem in total. I consider cos AT into cos BT by T. Right. So this will be equal to, I say again it is ft by t. So I should consider L of cos AT into cos BT. So cos AT into cos BT is what? So this will be equal to L of cos A into cos B is half of cos A minus B times T plus cos A plus B times T. And this is properties of the cos A cos B formula. Cos A cos B is half of cos A plus B plus cos A minus B. Sin A sin B is cos of A minus B minus cos of A plus B. This we have discussed in the one of the earlier classes also. So this will be what? half of L of cos A minus B times T plus, so this I have the flower bracket, L of cos A plus B times T, right? You may get confused by A minus B and A plus B. Usually they will give in a number. They will give in terms of number, cos 2t into cos 3t. Then this A minus B, A plus B becomes simple number, so that becomes easier. This is the generalized case. Now this will be equal to what? Half of, right? What is L of cos 80? It is half of S over S squared plus A minus B whole square plus S over S squared plus A plus B whole square. This becomes a problem because I should have negative sign here. I don't think cos A into cos 80 into cos BT is possible. Anyway, let me see. Let me see how we have to proceed, because log of, it will be log of S squared plus A minus B whole square, log of S squared plus A plus B whole square. So this I'll do it in the next class, because this plus is bothering. So therefore, see, I can say this is f of s. Therefore, L of cos AT into cos BT by T will be what? Will be integration from s to infinity half of s over s squared plus a minus b whole square plus s over s squared plus a plus b whole square dx. Right. So what this will be? This will be equal to, see what I should do. This will be half of, I write here, half of, right. So integration s to infinity, it is s ds over s squared plus a minus b whole square. Then plus integration from s to infinity s ds over s squared plus a plus b whole square. If it is minus, it becomes easier. Instead of cos AT into cos BT by T, if I consider sin AT into sin BT by T, it becomes easier. Because this will be minus. So what this will be? This will be equal to what? It is half of, right? So this will be equal to half of, this will be what? Log of square root of s squared, right? 1 by 2 times it will be s squared plus a minus b whole square plus log of square root of s squared plus a plus b whole squared from s to infinity. Right. So this is a problem for me, because this becomes product. Right. This will be product. So this won't reduce to finite limit at all if it is plus. So log of a plus log of b is what? Log of ab. Right. So this will be what? Half of, right, log of, it will be square root of a squared plus a minus b whole squared into a squared plus a plus b whole squared from s to infinity. This is a bit difficult because this is indeterminate. So this will be what? Half of limit as s tending to infinity. It is log of square root of a squared plus a minus b whole squared into a squared plus a plus b whole squared. So this goes to, this gives me infinity, so I won't get the answer at all. Minus log of the same thing, square root of, I have to put s is equal to s. S squared plus a minus b whole squared into a squared plus a plus b whole squared. So this won't give you 0 earlier cases, because if it is division, then I can take out a squared common, and this gives me log 1 and I get 0. So therefore, if it is sine 80 into sine bt by t, it is possible. Otherwise, it gives me infinity. So, no answer. No answer for this problem. I can't solve, I can't find the Laplace transforms. Instead of that, if I'm having sine 80 into sine bt by t, then I can easily find out the answer, right? So I'll stop here. I'll mail it to you in the in your Google class. I mail the uh, lecture notes also and video also in the Google class, so that you can go through these problems. In the next class, I'm going to consider Laplace transforms of derivatives and Laplace transforms of integrals. Those things we are going to study in the next class. I'll stop here. I'll end the meeting. Have a nice day. Goodbye.